Pasan asked me to talk about AI in qualitative analysis, and I think I thought I might have sort of expanded a bit and also talked about a few other parts of the research process in qualitative research. And I hope that at the end of this talk, you will have a bunch of new ideas of things that you might try, experiment with, and get your hands dirty. We've already had the brief introductions earlier, but just to sum it up and also have it in the recording, I'm currently a postdoctoral researcher in social data science at the University of Mannheim. I did my PhD in human-computer interaction at LMU Munich with the same supervisor as Passant. And back then I worked on language learning technologies on mobile devices. And I figured out that I was always interested in running studies, analyzing data. And then with some of the coincidences as they happen in life, I ended up working on data quality in the social science. Frauke Kreuter recruited me for a research project, and I'm now looking at the technology side of social sciences. Now, first of all, a bit of a background introduction, I would say, on AI in qualitative research. Why would I even do this? We've heard a few arguments in Paul's talk earlier already. I was actually very happy when I saw his talk on the agenda because I knew this was going to be a very good foundation for my talk. And we will have some of the arguments repeated there as well. So we've heard about aspects such as speed, flexibility. You can scale up to larger quantities. You can avoid costs. You can maybe gather new ideas, new perspectives. To some extent, there's also the idea that you might avoid human errors and also that you might protect participants who might be in a more harmful situation. But of course, this only holds to some extent. We've already heard a lot about limitations. So what I'm trying to do in this talk is to look at some of the advantages that you might expect, but also some of the issues that you might encounter when working with different AI tools or methods. A lot of this is based on an article that we wrote in the context of human-centered design, which was essentially about redesigning interaction design with AI, in the sense that we simulate what humans do in human-centered design with LLMs like ChatGPT. I will refer to a couple of elements of this talk, of this paper, but rephrase it, of course, in a way of qualitative research instead. But one of the main classifications that we did there, which I think is also relevant in other areas, is that we can have different roles of an AI in the collaboration process in research. On the one hand, we can have AI as an additional agent that is included instead of either human subjects or human researchers, for example, by generating scenarios, illustrations, by looking at, if you go into survey pre-testing, merging results that an AI tool gives you with something that an expert gives you. So just increasing the scalability of what you can already do before you move on to using a human expert. We also have in silico models by replacing humans that generate output from human-informed models that have consumed all the training data, you know. We can also, and that's a particularly interesting point, if you have ideas for that, they're very welcome. That is to extend the existing range of research methods. For example, you could have, instead of an actual interview, you would design a persona and then interview that person, or you would immediately summarize opinions without actually running a survey. You kind of cut out the intermediate step. Again, as I said, this is not a perfect method, but it is something that is at least interesting to try out, to experiment with and see where it brings you. And one more thing that I would like to present before going into actual different parts of the research process. This is from a paper on designing AI systems, actually. But I found it quite interesting in the sense that it actually considers how well an AI needs to perform and how difficult a task is. So on the x-axis, you see how the level of AI performance, if it's low or high. And on the y-axis, the task expertise that is required on the human side. And what you can see there is that this was a, let's say, some kind of review where they analyzed what tools designers come up with. And they figured out that many designers go straight into tasks that require a lot of human expertise, but where current AI performance is moderate. And this is a very challenging combination. What we rather want to go into is having either situations where we know, okay, the AI performance is excellent, we don't really need a lot of expertise, we can trust the AI fully, or we want something where we can already work with something where our expertise is good enough and we don't need a lot of expertise, so we can actually also work with a system that is not perfect yet. And this is really what I want to stress, that most of the tools we use, they have mistakes, but there's already a lot that we can do regardless of that. And we need to figure out the sweet point between how we can get support without running into the issues that come with the imperfections. And for that, I hope I can give some useful examples. As a summary of things we can consider in the research process, here are a couple of examples, and I will go into more detail later on. So we have the planning stage of research projects. Here, interesting AI tools could, for example, help us assess prior work, choose research methods, testing survey questions, or also helping us rephrase our research questions to be more concise, or something that hasn't been done before. Tools can support us in data collection by what I already mentioned, generating synthetic data, maybe also through data imputation for missing data in either unit non-response or item non-response. We can have validation checks. Does something make sense that a person entered in a survey or something that they mentioned in an interview? A big part is also analysis code writing, so support with programming in data analysis and data synthesis. I will also give an example of a thematic analysis, very brief, quick and dirty solution. Then documentation and presentation. We've probably all used some kind of AI tool for spell checks and maybe also for grammar or style improvements. We can make our text shorter or more expansive. We can add visualizations. And then one thing that is also, well, not really has a clear step in this pipeline, but I also find very relevant in the context is ethics and privacy. For example, being creative in using AI tools to hide someone's identity or to analyze the risks that might occur. Now, in the rest of this talk, I will bring a bunch of examples of different application scenarios for tools and prompts in some cases. I will also talk about what has already been validated as a method, what possible concerns were in this domain of qualitative research. I will have the broadest focus on the analysis stage of a research project, but will also bring a couple of hints on the others. And in the end, if there's still time, I will briefly talk about 2 case studies inspired by my colleagues that work in my group, Lea von der Heide and Olga Kononini. Oh my God, I practiced before how to translate this, to write this, but yeah. Good. Then let's jump right in with the first section of a couple of examples of what to do with AI tools when you have a new project. I just summarized this as first steps in a new project. And I will present something on retrieving and analyzing past work, but also inspirations for research methods. And as you can see, this image is clearly AI generated in a very bad quality, but I think this just goes well with showing how it works to some extent. It's not perfect yet, but I can work with it. And that is also the rationale behind this. Maybe you've seen something like that. So when we say, tell an LLM, for example, find me some references that state this and that, well, ChatGPT might as well just make them up. But does this really make tools like that useless in work analysis? I think no, because there's a bunch of things that we can still do. We can gather some first information. There's usually good summaries on generic topics in a relatively superficial manner that might give us a starting point on where to go. We can ask for keywords to search for. We can use tools that are more specialized for search, and we can create summaries from things that we don't have the time to read, at least to have this first step of gathering information before actually validating details. For example, I asked at some point the question, what is the Mensch und Computer Conference? This is one of the biggest, or the biggest German human-computer interaction conference. And I put this question into Google and also into ChatGPT. And what I found is that they both have somewhat comparable results. So we get a summary of what this is. The one from ChatGPT is a bit longer, but it's actually also quite well done, even though this is a relatively small domain in the sense that it's not something like explain relativity theory, but really a specific event that is not documented in dictionaries or anything, but is just present enough on the web to be incorporated into the training data set. What we obviously have in Google is that we have links that we can click on that bring us to the source of information, which is not the case here. But if we look at this in a search tool that is supported by AI, we can actually find combinations that do both. So this is an example of consensus. It is some AI-supported search tool where you can enter a question. In this case, I asked which factors determine transit mode choice, and it has a couple of references listed below with excerpts from that tells me, yeah, there are strong ties for driving, weak ties for public transit, depending on, okay, this is not actually the factors that determine transit mode choice, but something that has something to do with the social context in this case. But the one below actually has pretty good examples. So we have safety, reliability, comfort, travel cost, etc. And this can work because it combines methods of traditional information retrieval, gathers a bunch of sources that have something to do with a topic, and then has this AI or LLM top layer that generates summaries without losing the link to the sources, which is not possible with the compression we have in the big models, like big large language models, and thus it avoids hallucinations. Essentially the same as Bing Copilot as well, so from a non-research domain. This is, yeah, just as an example as well for this is an auto-generated summary based on the references that were in the previous image. Then I mentioned it's also interesting for finding keywords. So here's just a simple question again in the transit mode choice example. What are important keywords that I should search for? And then it gives me a list of keywords. I guess we will also hear something like that when we talk about systematic reviews this afternoon. And then my final example for past work is summary and reading. There are also tools out there like HumanE, which essentially takes HTML input or PDF input on the one hand, and then gives you summaries with links to parts of the source. So you can generate summaries and link those to parts of the text where they occur, which gives you a method for validating what you just saw. Also in the research planning stage, we have basic information, okay, what research methods are out there. To be honest, this is pretty generic. What I asked here is to briefly list suitable methods for qualitative research on commuters' transit mode choice. And it gave me examples of, okay, you can use interviews, you can use focus groups, you can use case studies. I guess this is what you've learned in your first initial class or introductory section on what you could possibly do. So I tried going a bit deeper as well. What are pros and cons of interviews, for example, in this specific context? And it had a couple of points that are interesting. It didn't bring me a lot of insights now. It wouldn't help me so well in deciding what method I would use, but at least it gave me a first step into checking what details I should look into for my further decisions. I had a list of pros and cons as well. Yeah. This is exactly what you would find in a book on this topic as well, but it's a convenient way of access. I think it would help if you then really go deep into, for example, I experimented a bit on this topic of transit choice mode as well, mode choice, looking at participant observation, which is of course a challenging part in this domain because you really need to follow someone in what they do without being observed, which is quite challenging for something like commuting. And then it gave me a couple of hints as well on what I could do there. But I would only use this as a starting point. Okay, now let's move on for more of another method. I combine it a bit in both in data collection and analysis because the tools that I found and looked into are quite broad in the sense that they fit several categories. But the concentration point here is really the survey component. And I will look at pre-testing, synthetic data, text analysis, and also AI support questions. First, some examples on how to create a survey. So one thing I thought would be interesting, how about I inform my questions from other surveys that have already been out there? So I asked what demographic questions are included in the Eurobarometer, which is a very large-scale panel survey. And it also knew about the survey, so it gave me a list of the demographic factors that are relevant there. And then I asked it to limit it to those that are also relevant for a survey on transit mode choice. And one thing that fell out, for example, is the religious affiliation, which might not be so relevant in that context, and it helped me narrow down a bit what I would still ask. So it's informed on something that other people have already validated, again, taking this human intelligence component, but combining it, narrowing it down, and simplifying the access to this. Then maybe some of you have seen this example of something that was posted on the CDU website not long ago. Unterstützen Sie die Forderung zur Rücknahme des Verbrennerverbotes? Ja, nein. It was a survey question that was posted as part of the electoral campaign. And it essentially asks if people want to take back the, how do you even say that? The fact that combustion engines were not supposed to be allowed anymore after 2035, I think. And then I asked what potential issues with this question might be. Responses that I got were complex language, leading question, lack of context, binary response options. So there's a couple of points that really are valid in the context of the survey. Others were also missed. For example, the double negation, which is usually challenging in surveys to really make people understand what yes and no means in this context. But the point I'm trying to make here is that it really helps as a first step, again, speeding up your process before you give your survey questions to a human to evaluate or to pre-test. How about you just run it through an LLM, ask if the questions are understandable there, and then that already helps you eliminate a few of the points that might come up later and save you cost in that case. When we're actually running a survey, this is just a very concrete example of something that we did in a survey where we studied how people use prompts, how they write tasks for GPT. We gave them a text box to enter their prompt. And in the Qualtrics interface, you can then just add a JavaScript command that sends this to a GPT engine or any other API and includes the response that you get in the survey question. And then we were able to build up this chat-like interface that includes your text and the response. Of course, this is now something where we actually asked people to write a prompt, but you could just do the same and, for example, ask them what their favorite hobby is, and then you would send it somewhere to classify if this is a sports activity or, I don't know, DIY activity, crafting, and then continue with this in future steps of your study. So there's a bunch of applications where you could use API calls to some LLM or other AI tool to then directly get a response while someone is responding to a survey. When you get answers, what do you do with those? Next example. So you'll see we are just going through a list of things that I find interesting. But one that is very obviously coming up in qualitative research is coding responses that you get. And I put all these screenshots here to show that this is really an active field of research. Most of them are archive papers, which means they're really recent. I hope that most of these will also end up in peer-reviewed journals at some point, but I think they will start to appear there as well. Yeah. And this is an example of, again, adding an AI agent to your system. Papers have analyzed different parts on a methodological point of view. For example, if LLM-generated choices are more generic than human codes, which is something that we might expect. They've also looked at what different kind of reasoning prompts do in changing the thematic codes that they derive and things like that. Of course, I also wanted to present an example of how this looks in practice with analysis that I did for a paper at some point. I used this paper that's listed in the title, so a paper on redefining qualitative analysis in the AI era by utilizing ChatGPT. And from there, I took prompts. So what I said, okay, here are responses of students explaining challenges they encountered in online teaching. That was the topic of my research. That each paragraph is by one student and that the responses should be read first. So I had this list of student responses. And then the second task was to do a thematic analysis and summarize, in this case, no more than 10 themes from the response set. This is what it gave me. So I have typical issues that might occur in online teaching, right? So lack of motivation, social isolation, technical issues, and so on that were present in the responses. And then I compared it to what our coders had actually said. By the color coding, you see that there are a couple of overlaps. Probably neither of the codes are ideal and should be resolved in collaboration, but you see that there's partially even exactly the same wording. For some of them, you can find similar concepts that are either split up or merged in different ones, but essentially show similar ideas. So if you do this in practice, things you could think about is either adding a coding agent that is an AI. You could ask it if you have multiple coders to look at the disagreements and then generate a third input from that, or even to generate initial ideas, then compare them with what you do to get a more fine granular analysis in this type of task. Now, so far I've presented concrete prompts, but I also have one tool that I studied in more detail because I found it very interesting as an abstraction layer that might be a bit easier to get started with, and also to run tasks in a series of manner rather than just doing this manually with one prompt in a row. And that tool is called Expected Parrot, domain-specific language. It is an LLM top layer tool, basically, for various survey-related tasks. For example, you can give it personas and then it will answer questions. It can simulate interviewers, and it could also be used for data labeling. They have a bunch of examples in the documentation that you cannot click on, but I'm also happy to share the slides if anyone is interested. And it's also an active package in development. I brought two examples now, but I've also looked at a few others. And as I said, there are a lot in the notebook examples, just to give you an idea of how you could use something like that. This is an example for generating synthetic data. And what I do here is I define an agent with specific traits. In this case, you are a 45-year-old woman. You live in the city of Mannheim in a small apartment close to the Neckar River, and you work as a dentist. And then I gave this persona the task to name 3 typical tasks that they perform at work. And well, I got dentist-specific output. As a dentist, 3 typical tasks I perform at work include conducting oral examinations, tooth extractions, filling cavities. Probably more nicely formulated than you would get this from a human respondent, but essential tasks are in there, and I can work with that as a first step to see if my question is sufficiently well formulated that I could get the responses or the type of responses I expect. With a similar idea behind it, but slightly different parameters, I can also simulate an interviewer. So the task that I had here is that I have an input of, say, respondents' statements on how they commute to work. And then I generate this kind of question that tells an interviewer to check all the boxes that apply for this particular respondent's response. And I asked them to say if the response contained an own car, someone's own bicycle, if they were walking, if it was a shared car or bike sharing, and public transport. And then I added a second question that was a binary question asking if respondents stated they use public transport or not. And then I gave it input in a long list with, in this case, again, generated responses because I didn't have a suitable data set, but you probably have, and you could run the same on actual respondents' data. So I had these 4 different responses, and then what the EDSL tool did was simulate an interviewer that would check the boxes that apply for this case, and it correctly extracted that the first one is subway, which is a means of public transport. Someone had their own car. Then it classified other for an electric scooter that I did not have in my initial response set. And there's also some of the things that I also saw there were other labeling tasks that essentially use any kind of input you have and then either simulate what people are doing or simulate what interviewers are doing. One thing they also suggested that I find quite interesting is to define or to use survey data that you already have to create personas and then ask these personas questions in a simulated follow-up interview. And thus you combine the data you actually collected with generative ideas. All of this was now lots of LLMs. I just want to mention here that you shouldn't forget about established NLP tools as well. So there's a lot of work on topic modeling, sentiment analysis, similarity measures. We heard stance detection before, automated summaries. All of this doesn't go away, of course. It's not as novel, so I will not talk about it in a lot of detail here, but I heard we have some experts in the room who can be contacted for that. I think I've already covered quite a wide scope now. I just have a couple of additional examples that are particularly well suited for qualitative interviews and focus groups and other methods, such as, again, preparation. We have visual support that we can generate, and also some convenience methods. First, I won't go into much detail here because we already talked about survey question generation, but for interviews, it might be interesting to go specifically into the way an interview is structured with a warm-up phase, then the meat of the whole thing and the cool down. So I asked here to give me a warm-up question for an interview on commuters' transit mode choice. And then it essentially says, okay, start telling me a little bit about your typical daily commute, how you get to work or school, and what factors are considered. It already contains a lot of information, so I might want to split this up into several questions, but it's a relatively easy one to start with, I would say, so it might really work as a warm-up. As a little helper, I could ask for invitation text. If I want to conduct a 30-minute interview with commuters and I give them 10 euros, it's online, write me an introduction invitation text. This is a pretty standard message, so this is also a task that works quite well. When I'm running a focus group, for example, I could ask for visual support. Say I want to have a quick draft of a hypothetical vehicle of the future. Then this is stable diffusion generated, so it's not top of the notch, I would say, but it already worked pretty okay for at least giving an idea of something that could be shown to participants in order to visualize something that doesn't exist yet. Another tool that is not really LLM-based, but that I also find worthy to explore is to augment tools such as diary studies or ecological momentary assessments by asking people to take pictures of a specific task or a specific moment that we want to study in order to reduce respondent effort on the one hand, but also to maybe increase the richness of information that we receive. Again, there's a bunch of APIs out there. For example, Google Vision performs really well. We have Azure Image Analysis, and to some extent also LLMs. What they can give you is either objects that are detected in an image, they can give you captions, or also specific themes that are associated with an image. For example, you could imagine this question, what did you have for breakfast? It's pretty simple to extract an apple from there, and then a mug, we don't really know what it contains, but we see that there was some kind of drink. And this could speed up response time on the respondent side, but also give you additional information about what actually happened, maybe even increasing objectivity in research. And then this last point that I also hinted at in my process diagram of what happens, that is kind of set apart from the subsequent steps, but also interesting, and that is AI for privacy. And here I want to go specifically into differential privacy approaches. The idea behind differential privacy is that you generate synthetic data that has the same aggregate statistics. And this is essential when you want to, for example, publicly make a data set publicly available that contains sensitive information. So what researchers have started to do is to fine-tune LLMs based on survey responses or maybe also interview transcripts, and then to synthesize new responses to the same question that overall, if you summarize it, overall participants give us the same output, but they don't contain any of the specific input material that we had. It's difficult to prove that a data set that is synthesized like this is actually not revealing any of the information, but I think it's a very promising research avenue to go further into this and to see what mechanisms we can find to make sure that there's really none of the initial training data available. For example, we could run checks to extract the information in both of the data sets, the initial one and the manipulated one, and then see to what extent we can still extract information from the original one that might be sensitive for someone's data. And so again, a screenshot of a bunch of research that is happening at the moment. Again, a lot of archive publications. It's been used in medical contexts or considered in the medical context, which is clearly a very sensitive one. But especially in the light of the push towards more open science, I think this could be worth to look into for data that we could otherwise not publish even though, of course, not all kinds of analysis are possible on not raw, but to some extent, manipulated data. This brings me to the end of my examples. I still have, or the concrete tools and application scenarios. I still have 2 examples that I would like to show from colleagues of mine. One of them concerns the European election. This is why I have this, again, not very pretty image of 4 white men sitting at tables with very pretty glasses. The first one is actually not yet related to the European Parliament, but another one that is similar to what I presented before with generating AI input while you're running a survey. And this is supposed to help occupation coding in surveys. And the process here is that you have a text box in the left window here, ask someone what their occupation is, and then based on some classification scheme, you would get options that match, or hopefully match, what you entered in the first field, to just limit the options that are presented in the second field. There's also still an other option at the very bottom. So in case the suggestions are no good, you can try again, but it might speed up the process and also the accuracy of the results that you get from a coding task that has a lot of different options. And then the second option, more on the quantitative side, is a method paper that explores how well language models represent German public opinion. The idea that the researchers had is to create personas based on survey data, then to prompt GPT with these personas and compare output to a benchmark. In this case, it's a German longitudinal election study. We already heard about this before as well. And then, yeah, to see what the numeric differences are between the personas that were created and the results that are predicted. An example persona could be this: someone who is 28 years old and female with a college degree. Then there's religious information, political stance information, a weak identification with a party, location where they live, and some opinions on common measures. Then the aim is to predict if that person voted and what party they voted for. Here's what they found in the first iteration of this project. As you can see, there are some clear tendencies where there are overlaps, but also interesting differences. We clearly see an overrepresentation of left-ish leaning parties, while AfD is definitely underrepresented in the GPT predictions. We also see that there are whether someone voted or not is also not the same with what was assessed in the survey and what GPT predicted. Now, they are also trying to do the same for the European election, and they've already run the personas. And there's a blog post out on the predictions. Let's see if this holds. I guess not, but we might have at least a hypothesis confirmed, which is that there's an underestimation of non-voting if we use a large language model, that there will be an overestimation of the vote shares for left parties. They actually based this initial idea also on a paper that tried to predict political orientation in English-speaking countries. This showed that this worked better than in German. So the hypothesis here is that it will work worse in non-English speaking countries, and that it will also not work as well if the native language is used for prompting, simply because English is still better at that. I'm very curious to see whether this will hold, how close it will be. We'll see next week. Okay, before I conclude, I have a few more things on working with AI research tools, with the obligatory robot handshake picture. go out there, search for prompting advice on various scenarios. I've linked one that is specific to research. The 11 chat GPT prompts for stellar research paper. You'll find that when you Google for it. Then this classic scenario of telling a model to act as a specific role, for example, as an interviewer or as a respondent, to perform a task and then to output the response in a specific format. There's another approach that is also helpful sometimes, is to, when a task is not perfectly solved in the first step, to ask, okay, what information do you need from me to get a good result? Core rules are definitely to be very, very specific in what you get, what you want, otherwise you'll get very generic responses. To bring examples, we also heard about this before, few short prompting. You might also ask why a decision was made the way it was. Of course, this response is again hallucinated in a way. We don't know if this was actually the reasoning that a large language model applied, but it might still bring up some corrections to the thinking, and there's some evidence that this works better if you ask a model to think step by step. And then to learn about the principles and limitations of the different models that we have. For example, one recent paper shows a bunch of synthetic data generation papers that are out there and synthesizes these by critically examining how well it worked. And then, of course, house talk. One more thing from the HCD paper was that we asked people to be transparent and honest about where they use tools, provide information about how they augmented the process or did not work. That is also very important part to mention. To be aware of limitations and biases, to try and actively mitigate them when you write prompts and when you check examples. Also by actually checking a lot of examples. And then think about if we can get information from AI tools that are actually of the same quality, if we find that it works well enough, then sure, go ahead, use this. We don't want to waste more people's time than we have to. It's already difficult enough to get survey respondents and interview participants. Good. Now, if you have time in September, then join us for our workshop on generative artificial intelligence and interactive systems. We still have a week for submissions. This might be more of an HCI focus, but we're also really interested in other domains of research. So if you have any experiences that you would like to share with us, look at the website and write a short position paper. It really doesn't have to be a lot. I think we also said like 500 words or less than that. And that's it.
Thank you once again for the presentation. I just referring to this slide with opinion biases, simulating opinion biases. In your experience with working with these AI agents, are there any representation biases in these simulating personas? And if yes, how you manage these biases?
If you don't pay attention to them, then they will not be managed for sure. There are a couple of things that influence how biased these personas are when you generate some. Oh, you mean the concrete election example, I guess?
No, I mean in your experience, the tendency that these AI agents are representing more Western European English-speaking persona.
They definitely do. There's a lot of research on that as well.
So when you're testing your surveys and all this stuff with these simulated personas, how you manage with these actual biases?
I think it really depends on the model, because there's a lot of movement to also counteract potential biases, especially from the big models. But if you use open source models, they will have stronger biases in a way because they're less constrained in what they output. But again, I mean, it's this typical problem, right? How do you get rid of the biases? Because so many of them are so inherently covered or latent biases that you don't find out about until you explicitly bring them to the forefront. I don't know. So avoiding them probably means looking at demographics, how they should be, compare that to what you get as an output, and explicitly say, I want to create personas that are in this age range with this background. Yeah, I think you just need to be more explicit if you want to avoid it, but there's no way. For example, when I generated responses to this transit mode choice statement, I asked it to give me 10 statements, and I think 7 of them were public transport, which probably doesn't represent a realistic picture. So yeah.
More of a practical question that I've found, or issue that I had recently. So that was with, I think, before. So I kind of felt in some of my latest prompts, like ChatGPT was trying to get me to do the work I wanted to do it. And I think I kind of clearly specified, okay, you're my assistant, this is what I want you to do. And then it came out like, it gave me some generic advice, and oh yeah, maybe you should do this. And I was like, this was essentially what you are supposed to do. And then I argued a bit back and forth, and then I got frustrated and because I felt, it takes me so long to figure out apparently how to prompt this correctly. I'm actually faster doing this by myself now. So I was wondering why that is. So I kind of had the feeling that I had was that I was kind of arguing with a very lazy assistant who was trying to get me to do the work. I wanted the assistant to do the work. Do you have any advice on that?
Well, one thing that I can think of is try not to go too far down the rabbit hole, because the problem, of course, in a conversation is that the conversation context from before is stored.
Mm-hmm.
And if you have a lot of information that you don't want in this context, then the responses that are built based on this might still have the responses from earlier that did not do what you want. So maybe one approach could be open a new window, try again, start again with what you've learned from the previous conversation, eliminate context in a way.
What I also found useful is actually reverting to older ChatGPTs. They weren't doing this. Like, this is happening with the 4 version, the ChatGPT 4 and higher. Mm-hmm. The 3 and 3.5 are kind of smarter in those dummy tasks. You ask for something, you get an output. Especially with the paraphrasing type of tasks.
Yeah, the problem here was actually I kind of wanted to get into literature research, and then the old ones are performing really badly there, and the new one was always like, oh yeah, you could look there, and I was like, yeah, that was what I didn't want to do.
And there are external tools to ChatGPTs that are doing a much better job than the actual chatting interface, which we will talk about in the next talk. So this would also have to.
I've also focused a lot on ChatGPT because we know it all, but of course there are a bunch of other models out there as well.
That's actually good because it bridges to what I was going to comment, because you already kind of like hinted at the open source models and other models that are available, where you don't necessarily have to transfer research data to the ChatGPT servers, which is also another privacy concern. Can you talk a little bit more on this? Because I think that kind of like for open science and transparency in science, that's where the true promise is, avoiding using the commercial tools and using more the open source tools.
I actually haven't done it myself yet, so I can't really tell you how well it works, but colleagues of mine have, and it's definitely, especially if you're on the method side, it's super interesting as a research tool because you can investigate how biases happen, what the activation layers actually have as an impact on the final result. You can circumvent the always nice and polite responses. So if you have time, look at this. But yeah, I mean, the problem is, of course, that the open source models are often not as performant in some of the tasks that we might want to use them for, because there's just so much work being put into OpenAI and Gemini and the other commercial models. So it really depends on, as again, it always depends.
Last question, then we take it to lunch.
Regarding the open large language models, I can strongly recommend Hugging Chat. So this is, Hugging Face probably, and Hugging Chat offers the possibility to use different open language models. All you need is basically a free account for Hugging Face, or maybe you can even try it out without one. And of course it depends on the task, but we had really good experiences with the Mixtral model, which is, it really is, right? And it performs very well on most of the tasks, but of course you should compare it to the larger ones. But there's also a larger mixed trial right now, right?
There is the mixed trial is a little bit complicated because they have several models. They have the mixture of experts model now, which is a super huge one, which is really good. But you can't run that on commercial hardware.
Right.
It needs. But yeah, but that's kind of in line. Also, based on all your building up on your suggestion, you mentioned Hugging Chat. There's also Olama, which if you have a GPU on your computer, you can actually run the models fully local on your computer. I have it on my computer installed, and it's really good. It's really fast in some cases.
They are also backed by Meta, so right, they have enough money. One thing that for the expected power tool that I mentioned, it's also possible to just specify 10 different models that run the same task, and then you can compare the output.